Let's talk about scale drawings. So today in class we learned about two ways to figure out if one drawing is a scale drawing of another. Now I have on the board here a Minecraft creeper who is searching for his creeper son. So the first method that we used was to look at the corresponding measurements on both drawings and to see if there is some scale factor which remains constant throughout the entire drawing. So let me demonstrate that here. This creeper has a body length of 5 inches. This one over here has a body length of 2 inches. Now the thing that you would have to multiply 5 by in order to get to 2, we write it out over here, 5 times what equals 2, that number is 5 over 2. 5 over 2. So now we're looking to see if the other measurements in this little creeper are also something that you can get by multiplying the measurements of this big guy by 5 over 2. Let's test his head. So his head has a length and width of 4 inches. Now 4 times what equals, and this over here is the corresponding measurement as you can see, 2 and 2, the head is a perfect square. 4 times what equals 2. Now, unfortunately, the answer here is 1/2, which, oh, I see that I did this one wrong up here. This should be 2 over 5. All the same, it doesn't matter because we can now see that this is not a scale drawing of this guy because the scale factor that you need to multiply by to get from 5 to 2 is 2 over 5, but the scale factor that you have to multiply by to get from 4 to 2 is 1/2, and these are not the same, and so this guy is not a scale drawing of the big creeper. Let's look at the second creeper and see what we can see about that. Alright, so let's first start with the head, 4 to 2, so 4 times what equals 2? Well, 1/2. We did figure that out in the last one. And now let's look at his body length. 2.5 inches, 5 inches. 5 inches times what equals 2.5? And would you look at that? It's actually 1/2, or 0.5 if we're doing decimals. So you can see that we've got these two measurements. They're both using a scale factor of 1/2. So good so far. Let's check out these measurements on the bottom over here. Now, I didn't have to check the measurements for the first one because as soon as I found that one of the measurements had a different scale factor than one of the others, I immediately knew that could not be a scale drawing. So to eliminate something as a scale drawing, you only have to find that there are two measurements that correspond and they don't have the same scale factor. So that's how we eliminated this guy. But let's look at this guy's feet. So they've got a height of 8 inches and a width of 0.75 inches. And then the height over here is 1.6, so I'm going to do 1.6 times what equals 0.8. Yeah, that's a 6. 0.8. Well, 1.6 times 1/2 equals 0.8, right? 1/2 of 1.6 is 0.8. And then that last measurement, 1.5 times what equals 0.75. And again, we get the answer of 1/2. So we know for certain that that creeper guy on the end has the same proportions as this first guy. We know that he is a scale drawing of the first guy, he can be reunited with his father as his creeper son, and that's all good. So I've been talking about proportions though. Proportions is an interesting word because proportion talks about how we compare the measurements within the same drawing. So far we've been comparing measurements from big guy to little guy, big guy to little guy, 4 to 2, 5 to 2.5, 1.5 to 0.75, 1.6 to 0.8. But what happens if we compare measurements within a drawing? So if we wanted to figure out if one thing was a scale drawing of another method we could use, which we learned in class today. So we've used our first method. It's comparing individual measurements from one to the other. That's one method. We're going to do the second one now. The second method we can use is comparing how measurements work within each drawing. So let's get looking at the body lengths of all of these. looking at this first guy, he's got a 5-inch torso, and then the width of his torso going this way would be the 2 feet added together, so 1.5 plus 1.5, that would be 3. So then 5, which is 3. I'm just going to keep that as a fraction so I don't end up with all sorts of crazy decimals. And now let's look at the other two guys. For this one, 2 inches is the length of his torso, and his width is 0.75 plus 0.75, which is 1.5. So 2 inches divided by 1.5 gives us 2 over 1.5, which is also equal to 4 over 3. As you can see, these are not scale drawings of one another because this one has a different proportion. So the width and length of his torso are not related in the same way as the width and length of this guy's torso. Let's check the last guy. So I'm just going to erase the second guy's. We already know that he doesn't match. And so by both methods, we've eliminated this middle guy. So I'm just going to cancel him. Oops, imposter. All right, let's check this guy. So we have 2.5 as the length of the torso, then width is 0.75 plus 0.75 to give us 1.5. So keeping that as a fraction, 2.5 over 1.5 is 5 over 3. You can see I just multiplied top and bottom both by 2 to get 5 over 3. These two match, which means that the proportions of their torso are the same. The relation of the length and width of the big guy's torso is the same as the relation of the length and width of the small guy's torso. Now, we could go on to check the feet as well, but I am not going to waste any more of your time. If you wanted to check them by yourself, remember the way you would do it is to compare how the length and width of this one relate to how the length and width of this one relate. So it would be like 1.6 over 1.5, and is that equal to 0.8 over 0.75? And I can tell you right now that it is, so this is the true son of the creeper. They are reunited. Happy ending for everyone, and happy ending for you because you now know how to figure out if one drawing is the scale of another.